Hi, good afternoon, everybody. Thank you very much for attending this chat about agriculture and return of investment. My name is Ana Sancho. I'm a key account manager for Libelium. I have been in the company for the last 4 years, taking care of those related projects to agriculture, water, and environment worldwide. I just wanted to give you a few highlights about the webinar and things to consider. We have a couple of associates here in the room with me, Angela and Javier, that we will be attending the chat and will be answering like short questions related to links, different technical guides, and also forms, contact forms in general. During the webinar, all the questions will be grouped for the final session, questions and answers. And after my presentation, we'll have time to open for discussion and to answer all those questions that attendees have during the session. And the other thing to consider is that if you don't have time to join the webinar, or if you need to log out in the middle of the webinar, in a couple of days, the presentation and the session will be hangout or uploaded into the webinar section of the Libelium website. And lastly, as you have already noticed, the session will be in English, so please, questions during the chat, I would appreciate to be in English. Thank you very much, and let's start. So this is how Libelium sees the world, smart world. We, as Libelium, deliver smart solutions, and we help to build the Internet of Things. Around the globe, commercial deployments based on Libelium's open and wireless sensor platform include applications such as air quality, smart parking, precision agriculture, smart cities, environmental monitoring, air quality, and so on. Some years ago, it was impossible to think about having real-time data of the most important parameters from rivers, lakes, environment, but nowadays it's a reality. We as a company, Libelium, we help solve problems in our society with wireless sensor networks to monitor continuously anything and anywhere. And the fact is that IoT is an evolution now and it's impacting every single market. So with our experience managing IoT projects, we see that the fragmentation in IoT is a reality to manage at any point of the whole value chain, no? From hardware, sensors, data analytics, both in geographical areas and business development opportunities. There's a big mess due to a lack of standards, so clear roles in companies. This fact evidences that we are driving really fast in this evolving market, and there's no games or rules set up in companies, motion, etc. And we see there's a rising demand of an horizontal platform or perspective for the IoT market. Wasmo, that platform, allows any player to be able to join at any part of the value chain: sensors, hardware, cloud, application, service. We have been in the market for a long time now, and we see always 3 common elements of any IoT project. Sensors, with which you already know that we integrate third-party sensors, and we have more than almost 100 in our portfolio. Any protocol, communication protocols, and cloud platforms. One of the main features of Wasmo is to be horizontal, to be able to connect or send the information from any sensor through or to the most well-known cloud platforms, Esri, Sophia, ThingWorks, through a wide range of communication protocols. LoRaWAN, Sigfox, 4G, Zigbee, etc. So what does the market demands? Transparency, interoperability, in order to avoid vendor lock-ins. For this reason, we have built a modular and horizontal platform, WASMode, which you can connect different boards and integrate different sensors to allow different applications. Plug and Sense would be the encapsulated option of Plug and Sense, a more ready-to-go solution. And Libelium would be the gateway that you can utilize in order to create networks, radio networks, star networks, mass networks, and where more than 40 different cloud platforms are integrated into the system. So going back to agriculture, what do we see, or what do I see as a great challenge in the smart agriculture sector? Farmers with poor training. So what do we refer to that? Most of the farmers do not invest in technology due to a lack of information. They do not know what is outside there, and if they do know, they don't know how to approach new technological implementations. Fields located in remote areas or isolated areas. So with my experience, I can tell you that most of the times, fields that are located in fields that need monitoring or they need improvement are located in very remote areas. So there's no cellular connectivity, there's no power, you need to rely on solar energy, so it's kind of difficult implementations. Low budgets to carry out projects. We're still in a market where there's a lot of single farmers. They don't belong, and they have just a few budget where they'll invest in human resources, or they'll invest in machinery, but not investment in technology. Most companies in the agriculture sector are very small, yes, just a few employees, and they don't have the budget, or they don't have enough human resources to train for, or even budget to train for technical experience or technical knowledge in order to implement new technical solutions or whatever is out there in the market. Global climate change. This is a reality, as you already know. There's been an increase of a couple, 2 or 3 centigrades. Seasons do not correspond or are not aligned with what we consider spring, summer, fall. And the fact is that just 2 or 3 degrees increase in temperature will change the way that a crop is developed or the crop is growing, will change how the pests affect to that specific crop. There'll be a lot of changes where before the farmers knew by experience when to harvest, when it was the best moment to treat. And now, because of climate change, things have been a little bit more different. And this relates to pests, no? There's a lot of farmers that just treat whenever they think they need to treat versus when is the right moment to treat. So, what does the Internet of Things do for agriculture? Well, the Internet of Things has great possibilities for the agriculture sector, helping farmers to improve product quality, reducing costs, losses, and also making decisions based on facts to try to be more efficient in general. And how do we do this? Well, I wanted to present 3 solutions of our portfolio of product that we usually use in combination in order to approach an IoT project in agriculture. The first one is a Smart Environment Pro solution, which is capable of measuring up to 16 different calibrated gas sensors, also particle matter, temperature, humidity, environmental parameters, etc. And these not only recalls for agriculture, countries throughout the world have a need, in many cases a legal obligation, to ensure air quality to meet a specific standards. And in this past years, it's become kind of mandatory through several international regulations to reduce emissions that could impact in the environment. Also, smart water and smart water ions that will allow you to measure basic parameters of water, basic parameters of ions, to monitor applications like water quality, rivers, lakes, sea, pollution in water, fish farms, etc. And in fact, one of the latest Technoavio reports states that the usage of smart water technologies or management technologies such as big data, sensoring, and monitoring in real time can reduce or can save more than $12 billion revenue per year. And last, but not less, our smart agriculture solution with up to 12 different parameters to monitor, from soil parameters, weather conditions, plant growth, and that can be utilized for any kind of crop application, vineyards, greenhouses, cocoa, cereal. The analysis of this kind of parameters will allow to do a service and to approach almost any single crop worldwide. So what are the main precision farming applications that we see happening in the IoT perspective, from the IoT perspective? Cost savings in terms of water, energy, fertilizers, pesticides, in general, to be more efficient, okay? And this is related also to be cost effective, to irrigate when it's needed, not when you think the plant needs it. Also, product losses, to be able to optimize your crop and your field the maximum as possible, not to be able to produce more than what is related, what is basically related to the field. To optimize farmers' daily task. Back in the past, there was a lot of farmers that usually lived close to their fields, but nowadays they're mostly in the city or they're very far away from their lands. So if they knew when they have to open the valves to irrigation on when is the best moment to treat, that makes their lives easier instead of going to the field and checking if that's the right moment. Generating real-time alerts about crops. That related to also monitoring weather conditions to know when is the best moment to treat for a specific pest or when is the best moment to harvest. And of course, planning the specific strategies, predictive models related to pests, related to harvesting, related to the best moment to prune, and so on. And with all this, I wanted to present, it's going to be a total of 6 case studies, different projects that my customers have developed in the past couple of years. They are related to improving crops in general worldwide. The first one is a case study in Italy. It's the whole project was based on trying to improve a smart irrigation system for kiwi production. So in general, I don't know if you're aware, but Italy is the second kiwi major producer after China. And kiwi fruit is one of the most sensitive fruits in terms of quality. They suffer a lot of hydric stress, so they need to be watered in the right moment. Also, one of the main features of this project, or I would say part of the development project, was to compare GPS connectivity versus Sigfox connectivity. What is best for the market? What is best for the agriculture market? Famosa, which is an Italian company that works on technology-based support for agriculture, is offering, in general, crop monitoring and management. They implemented Libelium's technology in order to develop an accurate irrigation system strategy for farmers with GPRS and Sigfox. The main aim was testing reliability and cost during 2016 in kiwi grow season. They used as a protocol, like I said, GPRS and Sigfox, and they were monitoring soil conditions like temperature and humidity for irrigation, and also they were monitoring growth of the kiwi using a dendrometer in order to prevent water stress and have the fruit grow homogeneously. The final user was not aware and did not suffer the difference in between GPRS and Sigfox. And the S3 farm include a module to help farmers in making decisions and giving them alerts about water situation, pathogens, and maturation. The system allowed farmers to have a prompt warning of any water stress and also to recover from growth deficit. After a year or so, the farmers in general saw an increase of the kiwi production in their fields. Now we're going to Australia. This is a smart agriculture project for plant material in a nursery to ensure crop health and reduce losses. So AgNob 8 is a company that was founded in 2015, but this family business has been there for more than 20 years, growing different plant material from all over the world in Arcadia, Australia. This idea of developing this strategically wireless sensor network in this area became part because year after year they were experimenting losses of not knowing what's happening in the greenhouse and trying to resolve the issue after some hours where the plant material has no solution at the moment. So they use different kinds of plug and sense. They use smart water plug and sense, metering plug and sense, Agriculture Pro plug and sense for soil temperature, soil humidity, leaf wetness, and air conditions. And also they use ambient control for luminosity for the plants. One of the main features, or what I was really impressed with this project, is that in a remote area outside of Sydney, they installed Wi-Fi networks all over the fields, controlled by the central office to allow Wi-Fi connectivity in order to send the data. Also, the cloud was designed by the members of AgNob and allows a real-time management system where the employees of the greenhouse know the temperature 24/7, conditions in the greenhouse, water quality for irrigation, water conditions to irrigate, and also reduces human error. One of the main objectives of the Cameron's nursery was to be able to act in the right moment versus to try to fix an issue after it happens, no? And year after year, they had a very high percentage of material, plant material lost. So they wanted to reduce human error, they wanted to improve crop yield, and they wanted to use technology that was affordable. This IoT project controls every parameter that affects crops, and in fact allows them to reuse the remaining water that comes from the greenhouse again into the irrigation system, which is one of the main problems in Australia, the lack of water in dry season. Now, of course, we're going back to Spain. I needed to mention Spain since we are in Spain, right? So this is a project, and this is a very interesting project. It's based in the south of Spain, Murcia. It's they created a smart garden system to actually be more efficient in general managing gardens in Spain. This was developed by a startup company in Telquia, placed in Ontinyent, which is Murcia, and they wanted to measure a lot of different parameters to make the life of gardeners more efficient. They measure water conditions, soil conditions, environmental conditions, and even security conditions to see and allow different people going into the gardens. The interesting thing of this project was that they used Sigfox as part of the connectivity option. They used the Sigfox network and deployment to send data every 10 minutes in order to manage at the right moment to irrigate for the gardeners and try to facilitate their daily task. The whole project during a year reduced cost in water and pumping up to 30%. Also, like I mentioned before, help gardeners to find the right moment to irrigate versus irrigating in the morning or the afternoon without really knowing the amount of water that was in the soil already. And also, the most interesting part is that the citizens had access to the data and were visualizing in real time the movements or the conditions of the park. These are a couple of pictures of the installation, and South Spain has also a lack of water. We do not get that much water in south of Spain. Now we go into the tropical, Colombia. Different project, improving banana crops. This was a project developed by research center in the Red Tecnoparque Colombia, the SENA. And basically, the production of bananas in Colombia represents 3.7% of the total exports in the country. Now, banana is the crop of bananas is a very sensible crop to climate conditions or difference of climate conditions. And when the winter comes, where it gets very humidity and the temperature drops down, the oxygen in the soil decreases. And this produces a predisposition for the crop to get a lot of disease, to get fungus, to decrease production. So this investigation project, which is a long-term project, wants to determine and wants to study the implementation of or the creation of new banana species that will lead to increase the production and to be more resistive to diseases. This project versus the other ones that I mentioned before was developed by the research center using OEM technology. They did not buy the encapsulated option. They bought the different pieces and sensors, and they built our own solution, their own solution. Also, they built their own cloud-based application. Like I mentioned, this project is a long-term project, and the idea is to implement the system in other banana crop plantations. The return of the investment nowadays is to improve environmental and agricultural sustainability and to promote production. Also, to be able to track the production, to be able to track the fruit. These are some of the installations in remote areas where it was really challenging, and then it was really, really far away from where the research center was. And again, mentioned that everything was developed with OEM technology. Now we're going back to Italy, where a couple of years ago, the fruit fly affected 90% of the Italian olive production, increasing the price of olive oil and decreasing the price of decreasing the price of the olive production in general. And Team Dev, which is a now medium-large company developing software and developing modules for agriculture monitoring in general, develop a system to create a module and to control fly pest in the olive groves in general. They started in Umbria, Italy, but nowadays they are implementing this solution internationally and along Italy. The impact of a fly is very important in olive, basically because one of the cycles of a fly happens at the end of the cycle of the olive tree where it's ready for production. And the impact of the fly in the olive fruit affects the acidity of the olive oil, where decreases the retail price, and of course, decreases the production in general, decreases the price to market. So, avoiding this pest at the end of the fruit cycle is very important to have a very high olive oil quality and to be able to sell the product in a very good price in market. Team Dev adapted our technology using GPRS and sending to their cloud, to a specific cloud, which was it's called Agriculus Olives by Team Dev, and it's based on an S3 platform and also Fireware platform. This allows farmers to have a very good support management system to be able to treat in the right moment and to be able to harvest also in the right moment. The combination of the data coming from the wireless sensor networks, they were using basically agriculture plug and sense, was combined also with drones, with flights, and also was combined with different pheromone traps where they were monitoring the amount of insect captured by the traps, and they were able to create a cycle model built based on the cycle of the flights. The return of the investment based on what we have gathered from farmers is approximately 1 year. This system allows farmers to increase production as much as to pay for the system itself. So approximately the return of the investment of implementing this kind of system and having farmers have real-time data of what's happening with their crops is approximately 1 year. And last case of study, I saved marijuana for the last case of study. This is a project implemented in the States, and is, it was implemented and it was designed and developed by my distributor, which I'm very proud of. And they're not only distributing Libelium's hardware, they implement, and they're very focused in the agriculture sector. They also design their own system, and they integrate additional third-party sensors in order to adequate the project needs. So as you already know, the challenge of the legalization of marijuana in various US states could boost over state legal cannabis recreation and medical sales between $6 billion in between 2011 and 2020. Sensor Insight, which I already mentioned, is an American company that provides industrial Internet of Things solutions. In this project, they developed a wireless sensor network to produce the highest quality marijuana in Phoenix, Arizona. This project was developed investing in best practices to provide maximum yield and high quality results to deliver the best quality product for the medical marijuana market. Also, medical marijuana plants require balance of light. They're very sensible, let me tell you. Require balance of light, temperature, environmental and soil conditions. And the way they developed the wireless sensor network was based, it was an indoor farming system, and they were monitoring environment, they were monitoring air quality, different gases, basically humidity, temperature, methane, and CO2 levels to ensure that the plants were getting enough CO2. Also, agriculture, they were monitoring soil conditions, basically temperature and humidity, in order to know how much water the plant needed to increase quality and production. And also, they were measuring water quality. They were measuring different levels of basic parameters like pH, oxidation reduction potential, and salinity. And within salinity, I mentioned calcium, nitrate, and chloride. Users of the system can receive alerts via email, SMS, so adjustments can be made in real time. Also, the platform that they use for the medical marijuana operator, they can visualize and analyze the information in real time using a Sensor Insight dashboard. They also have their dashboard for the agriculture market. These are a couple of pictures of how the indoor installation was deployed. And the operators were receiving SMS based on the conditions in order to track 24/7 how the plants were doing or developing, and in order to activate or deactivate the irrigation. Also, medical marijuana operators hope to see a 15 and 20% increase in savings over the next 2 years. In this case scenario, the protocol that they were used was 802.15.4 to be indoors, and they created a mesh network to send the information also to the gateway. However, this sensor insight, they also do deployments for vineyards where the main operation or the main protocol they use is LoRaWAN technology. Well, I have to say that I appreciate everybody that's on the other side of the presentation. And I wanted to mention that from now until the end of the year, we'll have other webinars available that you can also join based on different applications. And if you guys have any other questions, need more information, want to contact me for pricing, or if you have a project in mind for agriculture where you need some advice, please feel free to send me an email to a.sancho@libelium.com. Also, you have more information about the different case of studies and technical guides and www.libelium.com/case studies. And feel free to ask any questions now through the chat. I'll be happy to answer all of them. We still have some time, so now we can open to discussion. Okay. Question number one. There's not that many questions, so I'll be fast. Question number one. Are these technologies feasible to other cloud platforms or other companies? Yes. So one of the main features, I'm sorry I didn't go into very deep in technical aspects. I didn't want to get the public confused. So our platform is open source, allows almost everything to be done, no? We have our portfolio of solutions with sensors and clouds, but that's open to other sensors and to other cloud platforms. So if you are a system integrator and you want this information to be sent to your cloud, our platform will allow you to do that. Next question. I'm confused about the cloud implementation in the Australian case. Did the user provide its own cloud service, or was there a third party? So in the Australian case study, Agnob 8, my company, designed their own cloud platform, their own application. I'm not sure about the cloud platform they use. I think it was Amazon, but they used an open cloud platform and they built over it. So that's something that if you're a system integrator, you can do. You don't have necessarily to use the cloud platforms we have as partners. System maintenance and calibration of the sensors. Could be concerns of farmers. What is the best practice in service supports? Okay, so the farmer, that's the end user. Keep in mind that we do not go with end users. We always have companies in between that will give that support to the end user. The farmers should not be worrying about calibration of maintenance of the sensors, although there's a period of time where the sensors will need some kind of calibration or will need some kind of maintenance, like any other sensor deployed in the middle of nowhere, basically. But the end user is only accessing the service, whatever the system integrator or engineering company, agronomic firm develops, okay? It's just accessing the service. But eventually, you'll need to be able to do some maintenance on the sensors and devices. Okay. Any other questions from the public? It seems like more going through. My associates are trying to manage a lot of flow they're having, which is good. I'm getting another email with questions. Next one. Is there a kind of cloud, local cloud, or the gateway site to visualize the data in a local area network? Yes. So you want to work with the cloud? Yes. You know what you're doing with the data? Okay. If you don't want to pay for a cloud service, or if you don't want to have your cloud, you can still visualize the data, the raw data coming from the sensors at the gateway level. Or you can create a individual system that will allow to visualize your data in the network. The only thing is the analysis of the data is going to depend on the type of crop and what you want to achieve for that specific crop. But if you already know what you're doing with the raw data, meaning you know your temperature, you know your soil conditions, you know your crop conditions, and you just want that raw data to be able to interpret the data on your own and to be able to make a decision, that's fine. You can do that. But if you want to rely on a third party that will interpret that data for that specific crop, there's also applications available. So there's a lot of different things that you can do with the technology, but I just presented some end solutions. Next question. What was the result of the kiwi study in Italy? Did GPRS or Sigfox perform better? Okay, so yes, I have an answer for that question. So Sigfox was a better option versus GPRS. Why? Because the amount of data needed sometimes to make decisions in agriculture does not need to be that often. Probably measuring data once an hour is more than enough. Sigfox allows you to send data every 10 minutes, and the price for connectivity, if you have a Sigfox network, is approximately 10 euros per year versus the amount you need to pay for GPRS connectivity. So in general, the performance in between Sigfox and GPRS, Sigfox was the winner. Next question. Oh, sorry. Okay. I answered the one with GPRS and Sigfox. Oh, okay. I think Wasmode is a fantastic platform. Anyway, I don't think these are IoT applications. The examples you did are wireless sensor networks connected to the cloud, in some cases to a server. Is there any demo deployed so we can know what kind of sensors are used, how we collect and send and see the data using any app or web-based service? Yes. Okay. So we do not have a demo online, so you can see the type of data that you're gathering. But if you, I don't know who's the user of this question, but feel free to write to me, and I can send you more information about the type of sensors we use, the performance, technical expectations. I can send you examples of how the data is sent, and so on. Okay. The idea is what we can do with the raw data. I mean, there's a lot of different things we can do with the raw data. Again, if you know how to interpret the data, then you might not need an application or a cloud server. More questions. How do you set the KPIs for measuring a new project when it's about to start? For instance, Gateway has LoRa Gateway features too. The picture you showed from the implementation in Phoenix shows a solar panel indoors. Do you use the specific lights for these? Okay, let me clarify something. My marketing department does a wonderful job. They probably add a solar panel, but indoors they were using I'm sorry, I didn't pay attention to the picture, but they were using a USB connector. They have a cable that charges directly to the solar panel, but the picture illustrated a solar panel. Sorry about that. And then also, what kind of communication technologies do you have on the units, and how do you deal with the related challenges? So this is a very good question. In the beginning, I talked about the fragmentation of the market. where it could be a challenge sometimes, but in fact, this allows us to be able to adapt. Sometimes it's an inconvenience, fragmentation of the market, but in most of the times for the agriculture sector, allows you to combine the different technologies to approach and to be able to resolve the issues for an IoT project, meaning the kiwi the kiwi case study, they were comparing GPRS versus Sigfox because they both had connectivity there. But sometimes when you're in remote areas when there's no cellular, then you need to rely on radio technology. Then you implement radio technology. Let's say that you don't have cellular and you don't have electricity, then you can implement radio technology and you can use solar panels and a car battery for your gateway. So depending on the project, you use one technology or another. I try to illustrate different case studies based on different technologies. For instance, the nursery management project, they were using Wi-Fi because they created a Wi-Fi network. And it was in a not remote area, but I mean, it was in a very outdoor green area with not really close to the city. Other greenhouses projects that I have developed, we were using 802.15.4. Depending on the site, you use one connectivity or another. We have limited options of connectivity, meaning that sometimes when we deploy in the middle of nowhere in Asia, becomes a challenge also. But we do have projects that using 802.15.4 sending to the gateway, and from the gateway using satellite technology, we are capable of gathering all that data to be able to send it to the cloud. So when I get a customer with a project and the customer exposes me, like, this is what I need, how can we make it work? Then we try to adapt the technology and the different communication protocols, trying to fit or suit the project needs. Okay. Do you have any more questions? Do you guys have any more questions? Well, again, thank you very much for being here today. Please feel free to contact me if you guys have any other, if you feel that you need to, like, personal attendance or you need more questions. That's my email address, and I'll be very happy to respond or to attend or whatever is needed. Thank you very much and have a wonderful rest of the afternoon.